Good morning friends. In my last video, I explained you hydrocarbons. Now, today I will take and explain you about the alkanes. Now these my videos, they will be in continuation. Please go through to my all the videos. Now these alkanes, they are also known as the paraffins. Alkanes means when the carbon join by a single bond, that is a saturated hydrocarbon. Now these alkanes, they may be open chain or acyclic alkanes, and cyclic alkanes are the cycloalkanes. As the name suggests, open chain, that is the long chains, that is methane, propane, butane. These are known as the open chains, that is a cyclic alkanes. And second is cyclic alkanes means closed chain compounds. If we take three carbon atoms, they form a closed chain, that is cyclopropane. If they form the fourth carbon atom, it is known as the cyclobutane. In the same as cyclopentane or the cyclohexane. Now, open chain acyclic alkanes general formula is CnH2n plus 2. But in the case of the cyclic alkanes, when it forms a closed chain, the general formula becomes CnH2n, where n is the number of the carbon atoms, because in closed chain there is a loss of the two hydrogen from the open chain. Now we talk about the structure of the alkanes, and first compound, that is a methane, and methane form a tetrahedral structure, in which if we talk about the carbon, it has the sp3 hybridization, and this sp3 hybridization overlap the hybrids of the one as H2, that is overlapping. It forms the 4 sigma bonds. So in the case of the methane, 4 sigma bonds are formed by the sp3 hybridization of the carbon, and 1s1 hybridization of the hydrogen. They form the overlapping, it forms the sigma bonds. Now I will start preparation of the alkanes and the properties of the alkanes. Today I will explain you two reactions, that is Sabatier and the Saturn reaction, that is also known as the catalytic hydrogenation. And second is Wurtz reaction. You see, catalytic hydrogenation, it means hydrogenation of the unsaid hydrocarbons. It is also known as the Sabatier and Saturn's reaction, that is reduction. So if the unsaid hydrocarbons, that is ethane, ethyne, they undergo hydrogenation, that is reaction of the ethane and ethyne with hydrogen in the presence of the palladium or the nickel as a catalyst. That is the addition of the hydrogen takes place. CH2, that is ethylene, react with hydrogen in the presence of palladium, platinum or the nickel as a catalyst. Addition of the hydrogen takes place and it forms the ethane. In the same way, if we take ethyne, that is acetylene, here also reaction takes place with hydrogen in the presence of the palladium, platinum or the nickel as a catalyst. It forms the alkane. And in the same way, if we take example of the propyne, then it forms the propane. So this is known as the catalytic hydrogenation and is also known as the Sabatier-Saddel's reaction. So in this case, hydrogenation takes place, that is addition of the hydrogen on the unsaturated hydrocarbons. So it's a very important catalytic hydrogenation. Now the second from alkyl halides. It is known as the Wurtz reaction. In this reaction, if two halides, suppose ethyl bromide, react with sodium in the presence of the ether. Listen, from alkyl halides when react with sodium in the presence of the ether, that is ethyl bromide, two molecules, they react with two atoms of the sodium bromide is formed, and the C2H5, it forms the butane. Now if you see this reaction, it is a symmetrical reaction. It means two molecules of the same halide, they form this symmetrical alkane. But if we take methyl bromide and ethyl bromide, here both the alkyl halides, they are not symmetrical. When react with sodium in the presence of the ether, it forms the sodium bromide, and CH3CH5 form the propane, which is asymmetrical. Now, how to explain the mechanism of the Wurtz reaction? It was supposed that the ethyl bromide, two molecules, when react with sodium, it forms the sodium bromide and a intermediate free radical, that is ethyl, that is a free radical. Again listen, in Wurtz reaction, first a intermediate free radical is formed, that is ethyl bromide, two molecules, react with sodium bromide is formed, and then ethyl, that is free radical, is formed, and these two free radicals they join to form the symmetrical alkane, that is the butane. So it's a very important reaction, Wurtz reaction. So I just started the alkanes. In my next video, it is a series of the videos on the alkanes preparation and the properties and the different reactions. So if you like my videos, please share and subscribe, and please go through all the videos regarding the alkanes. Thanks very much.